welcome to the Sleepy Club. This is the place where curiosity drifts hand in hand with rest, where we learn gently as we fall asleep. Tonight's story takes us far beyond time itself, to the very beginning of everything, from the first spark of the Big Bang to the birth of stars and the world we now call home. As you listen, allow your body to relax completely. Let your thoughts float softly like stardust in the night. There's nothing to do, nowhere to be, just you, the universe, and the quiet rhythm of your breath. If you enjoy learning while you drift into dreams, don't forget to subscribe so you can join us again for more gentle journeys through knowledge. Now, sink deeper into comfort. Take a slow, calm breath in and gently let it go. Let your eyes grow heavy, your body grow still, and your mind open to wonder. We leave behind the noise of the day and begin our voyage through time, through space, to discover how the world was formed. At the very beginning, there was no light, no time, not even space, only a pregnant nothingness, pregnant with possibility. From this mysterious void erupted a sudden flash of creation, the Big Bang. In an instant, our universe was born. Cosmologists tell us this happened about 13.8 billion years ago, when the universe expanded faster than the speed of light for a fraction of a second, a phase known as cosmic inflation. In that first timeless moment, space itself unfurled like a new blossom. Energy crystallized into matter and light, and time's arrow began its journey forward. What existed before is beyond our comprehension. Perhaps a quantum fluctuation, or simply the fabric of space-time itself energized. But from that ineffable silence burst a chorus of creation. In those first fleeting moments, after inflation halted, all the energy driving it transformed into a primordial fireball. This is the moment we usually call the Big Bang. The newborn universe was an ocean of searing light and subatomic particles, a hot primordial soup nearly 10 billion degrees Celsius. In the first 1 second of time, fundamental particles like quarks and electrons swarmed chaotically. As the universe expanded and cooled slightly, quarks combined into protons and neutrons. Within minutes, protons and neutrons began to fuse into the earliest atomic nuclei, forming hydrogen, helium, and a dash of lithium diamond. This era of Big Bang nucleosynthesis produced most of the helium that exists even today. After only about 5 minutes, the young cosmos had expanded and cooled so much that no further elements could form. The matter was almost entirely hydrogen and helium, the simple ingredients that would later cook into stars. Still, at that point, the universe was far too hot for actual atoms to exist. Electrons were free, zipping through space, scattering light in every direction. For about 380,000 years, the cosmos remained an opaque glow, a bright fog where light couldn't travel far without bouncing off an electron. But as expansion continued, the plasma cooled. At last came a magic moment called recombination. Atoms formed as electrons settled into orbit around nuclei. For the first time, light could travel freely. The universe became transparent. That ancient light from the cosmic dawn still washes over us today as a faint afterglow. The cosmic microwave background, a whisper from the infant universe, a stubbornly persistent illusion of the past made present. To borrow Einstein's words, people like us, who believe in physics, know that the distinction between past, present, and future is only a stubbornly persistent illusion. Albert Einstein wrote, and indeed, when we catch the faint microwaves from 13.8 billion years ago, the past and present seem to touch. As the cosmic fog cleared, darkness fell. The universe had to wait for the first stars to shine. In that interim, hundreds of millions of years of night, there were not yet any stars or galaxies, just vast clouds of hydrogen and helium drifting through expanding space. It was a cosmic dark age, silent and still. We might imagine it as an inky night in the universe's childhood, starless and profound. But reality was at work in the darkness. Here and there, the gas was slightly denser, slightly cooler. Those patches of cloud began to draw in more matter, growing denser and hotter at their cores. And somewhere in that dark, perhaps 200 million years after the beginning, the first star ignited. Picture it, a pinpoint of newborn starlight piercing an eternal night. It may have been a short-lived blue giant, 30 to 300 times more massive than our sun, billions of times brighter. Zoom. Other stars followed, congregating in the first nascent galaxies. The lumpy clouds of gas collected into a dazzling architecture. The first stars collected into the first galaxies over a few 100 million years. With their light, the cosmic dark ages ended. The ultraviolet glow of those early stars began to rayonize the hydrogen gas around them, tearing apart atoms into protons and electrons again. Over the next several 100 million years, this starlight reionized almost all the gas in the universe. By the time the universe was about 1 billion years old, the cosmos became transparent in the visible and ultraviolet light we know, making the universe transparent to light as we see it today. In humanity's scientific creation story, this is how the stage was set for everything to come. Yet long before science uncovered these facts, human imagination was already grappling with the mystery of how something can arise from nothing. In the quiet of ancient nights, under the same stars that now twinkle above us, our ancestors spun luminous myths to explain the dawn of the world. They weren't so different from the scientific tale. In poetic metaphors, they too spoke of voids and waters, of cosmic eggs and acts of creation. In ancient Mesopotamia, for example, people told of a time when nothing existed but a primordial sea. The goddess Tiamat, symbol of chaotic waters, and her consort Apsu. In that myth, the younger gods eventually rebel against primordial chaos. The storm god Marduk rises to champion order. He battles the dragon Tiamat and splits a monstrous body in two, like a dried fish, to form the heavens from one half and the earth from the other. In doing so, he brings the first light and structure to the cosmos. One is reminded of the Big Bang separation of forces and particles, the cosmos taking shape out of a chaotic plasma. Similarly, Greek mythology begins with chaos, a yawning void, an emptiness without form and from chaos arose Gaia, the earth, the ever-sure foundation of all, and Tartarus, the abyss of the underworld, and Eros, love, the binding force. The Greeks imagined that Earth emerged after chaos, giving birth in turn to the sky, mountains, and sea. Love, Eros, was there from the start, a cosmic attraction, drawing things together. In a way, this mirrors how gravity, a force of attraction, drew structure out of the early universe's chaos. The poets speak through myth what cosmologists speak through mathematics, both grappling with the mystery of beginnings. Across the world, many cultures conceived of creation as an egg or a seed. In ancient Hindu philosophy, before time began, there was Brahmanda, the golden cosmic egg. Brahmanda, from Brahma, the ultimate reality, and Anda, Egg literally means the universe as a cosmic egg, representing the genesis of the entire universe within which all things originate. In Hindu cosmology, this egg hatches, and the universe cycles through vast epochs of creation, preservation, and dissolution. Pandai is a vision that evokes a sense of infinite rhythms. After the cosmic night, a cosmic dawn. After dissolution, rebirth. As the Rig Veda's poetic Nasadya Sukta muses about creation, there was neither non-existence nor existence then. Darkness was hidden in darkness, that one which came to be. Enclosed in nothing arose at last, born of the power of heat. The Hindus, like the Stoics of Greece or the Norse with their Ginong Gagap, acknowledged the perplexing question, how does something arise from nothing? What is nothingness, and can it give birth to something? In our modern understanding, even empty space seethes with quantum energy, perhaps not so different from a mystic's fertile void. The Mayan people of Central America envisioned creation as the work of divine thinkers in the dark. According to the Popol Vuh, in the beginning there was only sky and sea in gloom, until the gods, heart of sky, and the plumed serpent spoke the world into existence. They said, let there be earth, and land rose from the waters. These deities attempted to fashion worshippers to adore them. The first humans they shaped out of mud, but the mudmen crumbled away. The gods tried again, carving people from wood. These wooden beings could speak and multiply, but they had no souls and soon lost favor, to be destroyed in a flood, with survivors becoming monkeys in the trees. Finally, the gods found the right recipe, corn dough. They formed 4 ancestors of corn, and at last humans stood upright, beings of flesh and spirit made from maize, the sacred sustenance. Thus, humans are successfully created from maize. In the Maya imagination, humans literally are what they eat, children of the corn, born from the earth's food. As a gentle rain falls on a modern cornfield with that distinct smell of soil after rain, one can almost hear an echo of this creation story, the earth offering up life from its fertile ground. All these tales, Babylonian, Greek, Hindu, Mayan, and countless others, though wildly different in imagery, share a sense of wonder at being itself. They ask, how could the world be? Who or what set it in motion? Our scientific story, too, has its unfathomable moment, the Big Bang singularity, when space and time emerge from something we cannot yet describe. What is nothingness, and how does something emerge from it? Perhaps we will never know for sure. We give it names like the Big Bang, but the name is just a signpost at the border of the unknown. Whether we say, in the beginning God created the heavens and the earth, or in the beginning was a quantum fluctuation, we stand equally mystified at the moment of Genesis. In the cosmic silence before the first stars, one might imagine time itself holding its breath, if time even existed in any meaningful way yet. Philosophers and physicists alike puzzle over what time really is. St. Augustine once said he knew what time was until someone asked him to explain it. Marcus Aurelius, the Stoic emperor, reflected on the flow of time and impermanence. He noted how ephemeral all things are. Everything's destiny is to change, to be transformed, to perish, so that new things can be born. Indeed, in the cosmic story, impermanence is fundamental. The universe began in a state nothing like it is now, and it will continue to change. Stars live and die, galaxies collide and morph. Yet from each death comes new birth. The first generation of massive stars lived briefly and perished in colossal supernova explosions. But in doing so, They seeded space with heavier elements forged in their hearts. Carbon, oxygen, iron, the stuff of future planets and life. The universe is a grand interplay of destruction and creation. As Aurelius said, things perish so that new things can be born. Are these changes random, or do they follow some eternal pattern? Philosophers like Friedrich Nietzsche imagine time as a circle rather than an arrow. In his doctrine of eternal recurrence, he envisioned the entire universe and all events repeating endlessly, cycling through the same events over and over through eternity. In a poetic fragment, Nietzsche wrote, "Everything goes, everything comes back, eternally rolls the wheel of being. Everything dies, everything blossoms again, eternally runs the year of being. Everything breaks, everything is joined anew. Eternally the same house of being is built. Everything parts, everything greets every other thing again. Eternally the ring of being remains faithful to itself. In every now being begins. Round every here rolls the sphere there. The center is everywhere. Bent is the path of eternity." In this haunting vision, time is a circle, an ever-turning wheel, like the cyclical time of Hindu cosmology, or the seasonal cycles of nature. The line, the center is everywhere, evokes a universe where every moment is the center of time, all equally real, returning again and again. Modern cosmology does not literally embrace eternal recurrence. Our universe seems to be expanding towards a long cold future, not looping back on itself in time. But Nietzsche's philosophy was not astrophysics. It was a challenge to live as if you would relive each moment forever. Still, it resonates in a cosmos sense. The atoms in our bodies have likely been part of countless cycles, formed in ancient stars, blasted into space, integrated into new star systems, and eventually into us. In a purely physical way, everything dies, everything blossoms again, as stars and planets recycle matter. Yet, unlike Nietzsche's closed loop, our best evidence suggests the universe's expansion is accelerating. Driven by a mysterious dark energy, it seems time's arrow will not curve back but fly ever onward. The galaxies rush apart, faster and faster. Eons hence, stars will exhaust their fuel, galaxies will dim. Perhaps trillions of years from now, the universe will be a cold, thin mist of particles. This is a melancholy vision of the far future of the universe, one that could fill us with existential dread. But here we are, alive, at just the right epoch to witness the cosmos in its verdant youth. Galaxies still sparkling, life flourishing on at least one world. What a miracle that is. When we contemplate such vastness, we can feel very small. On a clear night, have you ever stood under the sky? Maybe a child lying on the grass, heart filled with wonder, and felt almost giddy with the scale of it. The Milky Way's band of stars looks like a gauzy whisper across the vault. It can make our everyday worries feel trivial, yet at the same time, those stars invite us into a grander story. We feel connected. The Sufi poet Rumi once gently chided, "Do not feel lonely. The entire universe is inside you." In those quiet moments, staring up, one might sense that this is true, that we are made of star stuff, that the atoms in our bodies were brewed in stellar furnaces billions of years ago. In that sense, we carry the universe within. We are not apart from the cosmos. We are the cosmos in the form of conscious, wondering beings. As science writer Carl Sagan famously said, "We are a way for the cosmos to know itself." Are we insignificant in the vast cosmos, or are we the cosmos become self-aware? Perhaps we are both, tiny and precious, fleeting and eternal. Rumi's wisdom reminds us that in our very souls, burns the same light as the stars. Thus, the dawn of time set the stage. The universe expanded, cooled, and filled with stars. In the silent depths of space, galaxies swirled into being, each a vast city of stars, islands of light separated by oceanic gulfs of darkness. In time, one particular galaxy, our Milky Way, would host an ordinary star halfway out from the center, and around that star would form a certain small blue planet. But to reach that chapter, we must weave through billions of years of cosmic evolution first, following the threads from the first atoms to the world beneath our feet. With the universe's basic ingredients in hand, hydrogen, helium, and gravity, doing its subtle work, the grand tapestry of galaxies began to form. In the beginning, galaxies were smaller and simpler than the giant spirals and ellipticals we see now. They grew by merging and accreting matter. The first stars, as we saw, were titanic and short-lived. They burned their fuel quickly, producing heavy elements in their cores through fusion, and then died in spectacular supernova explosions. In dying, they enriched the surrounding gas with new elements like carbon, nitrogen, iron, the elemental palette needed for planets and light. The debris of those first supernovae mixed with primordial gas and cooled into new clouds. In these enriched clouds, the next generations of stars were born. Over hundreds of millions of years, many cycles of star birth and death gradually built up complex elements throughout the galaxies. It's a slow alchemy. Stellar furnaces forging heavier atoms from lighter ones. Supernova forges blasting them out across space. We truly are made of stardust. Every atom of calcium in our bones, of iron in our blood, was created in some ancient star that lived and died before our sun even existed. Galaxies themselves started clustering into a grand cosmic web. Gravity drew galaxies towards each other to form clusters and superclusters, with dark matter forming an invisible scaffold. Between these nodes, stretched voids, vast reaches with few galaxies. From a distance, if one could see it, the cosmic web would look like a lacy structure. Filaments of galaxies like gossamer threads, converging at dense junctions where thousands of galaxies orbit their common center. It is a sight no human eyes will ever directly see. Yet our telescopes and maps of galaxy surveys have revealed glimpses of this structure. Amidst these countless galaxies, let us narrow our focus to one in particular, a spiral galaxy forming perhaps over 12 billion years ago, acquiring its elegant pinwheel shape as it cannibalized smaller protogalaxies. This galaxy, enriched by generations of stars, spinning with graceful arms, will one day be known as the Milky Way. If you can find yourself on a clear summer night away from city lights, you might see it as the ancients did, a milky band across the sky, which the Greeks fancied was the milk spray of the goddess Hera, and other cultures saw as rivers or pathways for spirits. It is our galactic home, containing a few 100 billion stars. In a quiet corner of the Milky Way, far from the violent starbursting core, there resided a giant cloud of gas and dust around 4.6 billion years ago. This cloud was unremarkable, one of many such stellar nurseries. But then something dramatic happened. Perhaps a nearby star went supernova, sending a shockwave that jostled the cloud. The cloud began to collapse under its own gravity, spinning faster as it shrank, just as a twirling ice skater spins faster when she pulls in her arms. The collapsing cloud flattened into a disk, the solar nebula, with most of the mass concentrating at the center. As pressure and temperature soared in that core, a new star ignited. Our sun was born, finally shining as a true star around 4.55 billion years ago. The remaining disk of gas and dust encircling the newborn sun was the raw material for planets. In the inner region of that disk, where it was warmer, only metals and rocks could solidify. In the colder outer disk, ices and gases could condense as well. Tiny dust grains collided and stuck together, building pebbles, then boulders, then mountain-sized chunks. Over millions of years, these protoplanets cleared their orbits and grew. By roughly 4.5 billion years ago, the planets of our solar system had formed. Closest to the sun, small rocky worlds: Mercury, Venus, Earth, Mars. Farther out, where it was colder, gargantuan balls of gas and ice: Jupiter, Saturn, Uranus, Neptune. Our Earth at that time was a hellish scene. As it coalesced from countless violent impacts, its surface was molten, glowing red-orange with fresh lava. The young sun's solar wind was sweeping away the last wisps of gas and dust from the system, leaving the planets to stand on their own. In these early turbulent days, Earth itself had a cosmic collision that would forever change it. A wandering protoplanet, about the size of Mars, likely struck the Earth off-center. The impact was cataclysmic. It vaporized the outer layers of Earth and the impactor, spraying molten rock into orbit. Within a matter of months, gravity gathered that debris into a spherical companion, the Moon. When we gaze at the Moon on a calm night, perhaps while hearing the distant hum of a train at night, or standing on a quiet balcony, we are looking at the ghost of that primordial collision. The Moon's existence is testimony to the chaos and creativity of those early years. It stabilized Earth's tilt and tides, and ever since, the Moon has lit the night for poets and guided the rhythms of life's calendars. After the moon-forming impact, Earth was a seething ball of magma. Over time, heavier elements like iron sank inward to form Earth's core, while lighter silicates rose to form a primitive crust. This process, called differentiation, gave us a layered planet, a dense iron core, eventually a solid inner core and liquid outer core, generating our magnetic field, a rocky mantle, and a thin crust on top. Earth was still extremely hot, with volcanic activity everywhere, but as the surface cooled, a solid crust began to take shape. Now imagine standing on that newborn Earth. Though you'd need a heat-proof, acid-proof suit, the sky is dark red with dust and volcanic gases. Meteors rain down without pause, leftover debris from solar system formation. The ground trembles with constant eruptions. There is no breathable oxygen, only a toxic stew of carbon dioxide, nitrogen, water vapor, perhaps methane and ammonia. And yet, even in this inferno, seeds of future life are present. Water, delivered in part by comets and asteroids from the outer solar system during a period of heavy bombardment, begins to collect as rain. It's hard to imagine rain in such a landscape, boiling off almost instantly on contact with hot rocks. But over millions of years, persistent rainfall, and possibly water from deep within Earth via volcanic outgassing, gradually formed puddles, then seas. By around 4.4 to 4.3 billion years ago, Earth likely had a solid crust and pools of liquid water. Astonishingly soon after the planet's birth, some tiny zircon crystals found in ancient rocks are that old and appear to have formed in the presence of liquid water, hinting that the first oceans may have appeared as soon as Earth was cool enough. In our minds, let's fast forward to a time-lapse of Earth's early eons. The epoch after Earth's formation is often called the Hadean, named after Hades, the Greek underworld, for it was indeed like an earthly hell. Yet even hell can give birth to life. Comets and meteorites bombarded Earth, especially heavily, around 4.1 to 3.8 billion years ago. A period dubbed the late heavy bombardment. They likely delivered significant amounts of water and organic molecules, the seeds of chemistry. Even as they caused cataclysms, we can imagine the smell of wet earth as the first rains fell on cooling basalt, a scent we still find soothing eons later after a summer storm. Those rains filled basins that became the first seas, warm and rich in minerals, under a dim sun. The sun was fainter back then. It is in these primordial seas that something miraculous is thought to have happened, the origin of life. How exactly life began is one of science's greatest mysteries. Perhaps in a warm little pond, as Darwin mused, rich in chemicals, periodically dried and refreshed, concentrating organic compounds, or perhaps at deep-sea hydrothermal vents, where mineral-laden hot water gushes from the ocean floor, creating natural chemical reactors. Some theories envision life's building blocks forming in shallow sunlit pools, sparked by lightning or UV radiation. Others see life's cradle in the dark ocean depths, where volcanic vents provide energy and catalysts. Whatever the venue, by around 3.8 to 3.5 billion years ago, we find the first evidence of life on Earth. Microfossils and chemical signatures in ancient rocks from Greenland and Australia suggest that microbial life, simple single-celled organisms, had emerged by then. Our planet, once molten and lifeless, had grown a skin of life in its oceans. In the hush of a modern library, a scholar might run a finger over a fossilized stromatolite, its banded domes, built by cyanobacteria in some Archean sea billions of years past. It's humbling to think that life's story on Earth began so early and has been continuous ever since. Through asteroid impacts and ice ages, through continental drift and cosmic radiation, an unbroken chain of living cells connects us to those first microbes. We often narrate this epic as if life were an inevitability, but perhaps it was a rare accident, a lucky concatenation of molecules into self-replicating patterns. In any case, once life took hold, it began to transform the Earth utterly. We step into the next act. Earth's surface has cooled enough to support vast oceans under a dense, cloudy sky. This is Earth in the Archean Eon, roughly 4 to 2.5 billion years ago. The oceans are like a greenish broth, rich in dissolved iron and chemicals, lapping against volcanic islands. The air is still unbreathable for us. It's mostly carbon dioxide, water vapor, nitrogen, maybe a bit of methane and ammonia. But within the oceans, something stirs. Perhaps in a shallow lagoon, waves gently splash against rocks, and each retreating wave leaves behind a thin film of organic molecules accumulated from the sea. The next wave adds more. The sun's warmth causes wet-dry cycles, concentrating the molecules. Fatty acids naturally form membranes. Simple nucleic acids and amino acids link in chains. Could it be here that a tiny, fortuitous loop of reactions becomes capable of making copies of itself? Or maybe, deep below, at a hydrothermal vent, where superhot water meets cold ocean, microscopic pores in rocks create cell-like chambers. Within these natural compartments, proton gradients and catalytic minerals drive the first metabolic reactions. We do not know exactly how non-living chemistry bootstrapped itself into living biology, how mere molecules began to eat, grow, and reproduce, but by around 3.5 billion years ago, definite microfossils of bacteria appear in the rock record, such as in stromatolites, layered mounds built by microbial colonies. These early life forms were prokaryotes, microbes without a cell nucleus, likely resembling bacteria and archaea we know today. They fed on simple chemicals. Some may have harnessed the energy of chemical gradients in hot springs. Later on, a revolutionary group developed photosynthesis, using sunlight to turn carbon dioxide and water into sugar and oxygen. Life remained single-celled for an extraordinarily long time. For billions of years, microbes ruled the world. If we had a time machine to visit Earth, say 3 billion years ago, we wouldn't see trees or fish or even algae. Just an alien world of microbial mats in the ocean shallows and perhaps colorful pigmented bacteria in the water. And yet those tiny cells were terraforming the planet, particularly the cyanobacteria, blue-green algae. Performing photosynthesis, started releasing oxygen as a waste product. At first, the oxygen they produced rusted the dissolved iron in the oceans, hence banded iron formations in ancient rocks. But eventually, around 2.5 to 2.4 billion years ago, oxygen began to accumulate in the atmosphere. An event aptly named the Great Oxidation Event. Oxygen was actually toxic to many earlier anaerobic microbes, causing perhaps one of the first mass extinctions. But for other life, oxygen opened new possibilities, like the much more efficient aerobic respiration. The sky, once probably orangish with haze, turned a clearer blue as the atmosphere changed. This was the work of unassuming bacteria, breathing invisibly in the primal sea. On some starlit night, if you walk by the ocean and catch the faint smell of salt and seaweed, consider that the ocean's smell and chemistry were crafted by living beings over deep time. The smell of the ocean after rain, the salt on the breeze, all part of a cycle shaped by life interacting with Earth. There is a profound serenity in knowing that the oxygen each of us inhales with every breath was made by billions of little cells toiling in sunlight from the time of the first stromatolites through the age of jungles and into our present day. Life's early chapters are not well known to us. They lie hidden in ancient metamorphosed rocks with scant fossils. It's like reading a book with many missing pages. Yet, all around us in the DNA of modern organisms, clues remain. We know, for instance, that at some point, perhaps around 2 billion years ago, a transformative partnership was formed. One prokaryote engulfed another, and instead of digesting it, formed a symbiosis. The engulfed cell became the mitochondrion, the powerhouse of the cell, and the host became the first eukaryotic cell, cells with nuclei, which all plants, animals, and fungi are made of. This endosymbiosis gave rise to complex cells, which could eventually build multicellular bodies. Later, another symbiosis occurred. Some eukaryotes engulfed photosynthetic bacteria, turning them into chloroplasts, birthing the lineage of algae and plants. The stage was now set for a flourishing of forms. Still, for a very long time, life remained mostly microscopic and aquatic. The Earth of a billion years ago had oceans teeming with plankton and bacterial films on the seafloor, perhaps some slimy algae in the shallows, but nothing yet resembling the plants or animals we know. Time drifted on. Continents merged and broke apart, forming supercontinents. Volcanoes and weather worked on the atmosphere. By roughly 700 and 2635 million years ago, Earth experienced severe ice ages, the snowball Earth episodes, where it might have frozen over entirely or nearly so. Life survived those deep freezes, somehow, in refuges of liquid water, maybe near hydrothermal vents, or where the ice was thin enough for sunlight to penetrate. And when the deep freeze ended, life seemed to respond with a burst of innovation. As the Precambrian eon gave way to the Phanerozoic, the current eon, about 541 million years ago, Earth's oceans truly came alive with visible complexity. In a relatively short span known as the Cambrian explosion, an astonishing diversity of life forms blossomed in the seas. For the first time, animals with hard parts like shells and exoskeletons appeared in abundance, leaving a rich fossil record. The Cambrian oceans, around 500 million years ago, swarmed with strange creatures, trilobites scuttling along the seabed, their compound eyes surveying the dim undersea light, soft-bodied worms and mollusks, spiny predators like Anomalocaris, and the first primitive chordates, which were our distant ancestors. Why did this explosion of diversity happen then? Well, perhaps oxygen levels had risen enough to support higher metabolisms. Perhaps the evolution of predation sparked an evolutionary arms race leading to shells and spines. Perhaps genetic complexity, like the evolution of Hox's genes that pattern animal bodies, reached a tipping point. In any case, the great tree of life suddenly sprouted many new branches. Practically all the major animal body plans emerged in that time. If one could snorkel in Cambrian seas, one would see many forms that seem alien, yet also some that are familiar in outline. One might recognize an ancient arthropod analogous to a shrimp, or a primitive echinodon somewhat like a starfish. From that point on, life's story unfolds in a tapestry of radiations and extinctions, innovations and experiments. The Ordovician period saw the first vertebrates with true bones, like jawless fish with bony armor, and the beginnings of life's conquest of land with simple plants and invertebrates creeping onto damp shores. The Silurian and Devonian periods, roughly 440 to 360 million years ago, witnessed fish diversify, sharks cruising ancient reefs and lobe-finned fishes exploring stagnant swamps. By the late Devonian, some brave lobe-finned fish, pushing through murky shallows with stout fins, gave rise to the first amphibians, vertebrates taking their first clumsy steps on land, gulping air with primitive lungs. In the warm Carboniferous swamps, 300 million years ago, amphibians flourished and gigantic insects buzzed in oxygen-rich air. Lush forests of ferns and clubmoss trees rose from boggy soils. Their remains would become coal seams, the very coal we might burn now to boil water for a nightly cup of tea, releasing that ancient stored carbon back into the air. During those Carboniferous days, if one were to walk through the swamp, besides being terrified by dragonflies the size of seagulls, one might hear the croak of enormous primitive amphibians in the ferny undergrowth. The ground, soft and moist, would smell of decaying plant matter, a rich, peaty fragrance. Life on land had truly taken hold. Not just low plants and arthropods, but now tall trees and the first reptiles. By evolving the amniotic egg, a wondrous little life support capsule that prevents desiccation. Our reptilian ancestors liberated themselves from needing water to reproduce. This was a key turning point. Eggs could be laid on dry land, safe from aquatic predators, containing all the water and nutrients the embryo needed. Reptiles spread into drier habitats, and soon different lineages arose, some of which would lead to dinosaurs, birds, and mammals. Of course, evolution is not a steady march upward, but a branching bush with many dead ends. Earth's history has seen at least 5 great mass extinctions that pruned life's diversity dramatically. The end of the Permian period, 252 million years ago, brought the worst known extinction, the Great Dying, likely caused by massive volcanic eruptions in Siberia that led to catastrophic climate change. Up to 90% of marine species perished. It was a dark time. Perhaps the oceans turned anoxic and emitted deadly gases. Yet, life rebounded. From the survivors arose new dynasties, most famously the dinosaurs. The dinosaurs, those almost mythical beasts that fire the imagination of every child and many adults. They ruled the Mesozoic era, particularly the Jurassic and Cretaceous periods, roughly 200 to 66 million years ago. The world of the dinosaurs was warmer than today, with high sea levels and no ice caps. Conifer forests and flowering plants, which evolved around the mid-Cretaceous, carpeted the land. Enormous herbivorous dinosaurs, like Brachiosaurus and Triceratops, thundered across plains. Fearsome carnivores, like Allosaurus and Tyrannosaurus Rex, stalked them. There were also small dinosaurs, some feathered, the ancestors of birds. Overhead, pterosaurs, flying reptiles, soared, and in the seas swam giant marine reptiles like plesiosaurs and mosasaurs. Consider a late Cretaceous scene, a humid twilight in what is now North America, 68 million years ago. Cicadas hum in the magnolia trees, for flowering plants are now widespread, perfuming the Cretaceous air with sweet scents. A herd of duck-billed Edmontosaurus moves warily along a riverbank, their calls echoing in the gathering dusk. Fireflies, yes, insects much like modern ones, twinkle over the water. Suddenly, from the forest edge, a colossal T-Rex bursts forth in a swift ambush. The hadrosaurs bellow and scatter. One juvenile is caught in those powerful jaws. This drama of predator and prey, of life and death, is as old as life itself. Only the cast of characters changes, and far above, a new star might be visible in the evening sky. Perhaps it's not a star at all, but a large asteroid silently cutting across the heavens on a collision course with Earth. We all know how the story of the dinosaurs ends. 66 million years ago, a city-sized asteroid struck the Earth near the Yucatan Peninsula. With the force of billions of nuclear bombs, the impact and its aftermath, shockwaves, wildfires, a nuclear winter of dust blocking the sun, caused the fifth great mass extinction. The non-avian dinosaurs perished, along with about 75% of all species. It was the end of an era. Literally, the end of the Mesozoic, beginning of the Cenozoic. In the devastated world that followed, the small, adaptable, and hidden survived better, including our mammalian ancestors, who at that time were mostly small, shrew-like creatures scurrying in the shadows of dinosaurs. With the giants gone, mammals rapidly diversified into the open niches. Within a few million years, there were proto-primates leaping in the trees, ungulates grazing, early rodents scuttling, and, even returning to the seas, ancestors of whales. The world cooled and forests gave way in places to grasslands. Grasses themselves proliferated after the extinction. The stage was set for the rise of humankind, but not just yet. Before we move on to humanity, let's pause and reflect on this immense tapestry of life's evolution. It humbles us to realize that for most of Earth's history, humans did not exist or even remotely figure into the picture. We occupy just the latest milliseconds of the cosmic calendar. The age of microbes lasted billions of years. The reign of dinosaurs, over 160 million years. Modern humans, our species, have existed for only about 300,000 years. A blink. Yet in that blink we have probed so much. We've uncovered the stories of creatures long extinct, read the archives in rocks, understood the DNA language that connects all life. Sitting perhaps in a cozy armchair with a cup of tea, flipping through an old book of natural history by lamplight, one can't help but marvel at how these disparate pieces, fossils, genomes, geology, have been woven by us into a coherent narrative. It is a testament to the human intellect and imagination, our desire to know. The quest to understand the cosmos and our own origins is as much a part of us as love or hunger. Galileo, poring over his telescope observations in a dimly lit 17th century room, was motivated by that quest. So was Charles Darwin, scribbling in his notebook aboard the Beagle, pondering the transmutation of species. And so are we, each time we gaze at the stars, or examine a seashell, and wonder how it came to be. The philosopher Baruch Spinoza might say this is because we ourselves are part of the natural order and seek to understand God or nature. In Spinoza's view, the two were one and the same. Spinoza wrote that the eternal and infinite being we call God or nature necessarily acts as it does. That everything follows from the very nature of this one substance. In other words, the cosmos unfolds according to its inherent laws, and we, being modes of the cosmos, find meaning in comprehending those laws. Spinoza saw God in the unity of the universe. For him, to understand the cosmos was a kind of spiritual love. Einstein, who admired Spinoza, famously said he believed in Spinoza's God, meaning not a personal deity, but the awe-inspiring lawful harmony of the universe. One cannot explore these vast spans of time and space without philosophical reflection creeping in. What is the meaning of it all? This question has echoed down the halls of history. When Nietzsche speaks of eternal recurrence, or Marcus Aurelius of impermanence, or Rumi of our oneness with the cosmos, they are grappling with meaning in a cosmic context. Is there some teleology, some goal to this universe's story, or is it a grand unfolding poem, meant not for an audience, but as an expression of what is? Perhaps meaning is not out there, but in how we experience and cherish the universe's story. When we feel awe, when we feel connected, we imbue the cosmos with meaning through consciousness. Hannah Arendt, a 20th century philosopher, considered what it means to be mortal, to live a life of action in a world that will outlast us. She observed that if life were too easy, too immortal, it might lose meaning. For mortals, the easy life of the gods would be a lifeless life, Arendt wrote. Indeed, part of what gives our existence savor is its fragility. Because we are mortal, each moment glows with a certain preciousness. If we lived forever like untouched gods, perhaps we'd lose the urgency that impels us to create, to love, to remember. Arendt's insight that a life without struggle or effort would be lifeless resonates deeply. The backdrop of death, the knowledge of our finitude, is precisely what motivates human beings to seek immortality in deeds, in art, in memory. The stars themselves are mortal. They exhaust their fuel and die, and in that they share something with us. If the universe itself will someday fade, then all that happens within it is a kind of glorious tragedy, like cherry blossoms, blooming brilliantly and falling. But as we reach the emergence of humankind in our story, we also reach the emergence of beings who contemplate these very questions of time, mortality, and meaning. We are about to witness in our narrative the universe becoming aware of itself, through us. From the aftermath of the dinosaurs' demise, mammals rose and diversified. Among them, in Africa's lush forests and expanding savannas, a lineage of primates was evolving in remarkable ways. By around 30 million years ago, ancestors of monkeys and apes thrived in trees. By 7 million years ago, an ape in Africa diverged into two lineages. One would lead to chimpanzees, the other to us, the hominins. Walking upright, at least part-time, turned out to be our lineage's specialty, possibly an adaptation to mixed forest and grassland environments where foraging on the ground became important. Imagine a scene around 3.2 million years ago. in what is now Ethiopia. A river meanders through a mosaic of woodland and savanna. A rustle in the tall grass reveals a small group of Australopithecus, afarensis, early hominins. One of them we know as Lucy, from a nearly complete fossil skeleton discovered in 1974. They are diminutive, about a meter tall, walking on two legs though still adept at climbing trees. They have ape-like faces and brains not much larger than a chimp's, but they carry themselves differently. Their hands free to gather food, perhaps carry infants or sticks. These early hominins likely had no idea their descendants would someday send rockets to the moon or ponder the Big Bang. They were simply surviving, foraging fruits and tubers, maybe scavenging meat, avoiding predators like big cats or hyena. But walking upright was freeing their hands and perhaps encouraging social cooperation. Over time, tool use emerged. Stone flakes for cutting, bones used as digging sticks. By 2.5 million years ago, we see the first simple stone tools in the record, Oldowan tools. With tools, our ancestors could access new foods, butchered carcasses, tubers, which may have helped brain growth. Homo habilis is an early member of our genus, around 1.5 million years ago, known for using tools. Then came Homo erectus, around 1.8 million years ago, taller, with a larger brain and a more human-like body proportion, longer legs suited to long-distance walking and running. Homo erectus was a pioneer. They were the first to leave Africa, spreading across Eurasia. They likely mastered the use of fire, which was a game changer, providing warmth, protection, the means to cook food, which makes nutrients more digestible, and a new social focus. One can easily imagine Homo erectus campfires under the stars, the flicker of flames on faces, and perhaps the first truly human conversations, whatever primitive language they had, stirring embers of culture. As time went on, multiple human species coexisted. There were the thick-browed, robust Homo heidelbergensis, and later the stocky Neanderthals in Europe and Western Asia. In Indonesia, the diminutive hobbits, Homo floresiensis, lived on Floresiensis recently as 50,000 years ago. In Central Asia, the mysterious Denisovans left traces of their DNA in modern Melanesians. Ours, Homo sapiens, emerged in Africa roughly 300,000 years ago, as evidenced by fossils like those from Jebel Irhoud in Morocco. Anatomically, these early Homo sapiens looked much like us. For a while, they probably lived similarly to other humans in nomadic hunter-gatherer bands, but something was different in our lineage's brains or cognitive wiring. By around 100,000, 70,000 years ago, signs of symbolic thought and complex language appear. Beads made from shells, ochre used as pigment, perhaps early ritual burials. We underwent what some call the cognitive revolution, a flowering of imagination. Armed with sophisticated language, Homo sapiens became consummate storytellers and planners. Cooperation at larger scales became possible through shared myths and abstract concepts. Our ancestors began to leave Africa in waves, starting around 60,000 years ago. They spread into the Middle East, then Europe, encountering Neanderthals, into Asia, and eventually Australia by 50,000 years ago, likely crossing the sea with simple boats or rafts, an astonishing achievement for the time. At the time, by about 15,000 years ago, humans had reached the Americas, completing our settlement of all habitable continents. In every land we adapted to Ice Age tundras, tropical forests, high mountains, and arid deserts. We see evidence of their passage in cave paintings deep in European caverns. Flickering torchlight illuminating horses, and bison painted with surprising realism and grace at Lascaux or Chauvet. We find carved figurines, like the Lion Man of Hohenstein, a 40,000-year-old ivory sculpture of a humanoid with a lion's head, speaking to a rich inner world of myth and creativity. One can imagine a scene in a candlelit cave, or rather, a fat lamplit cave. A circle of our Homo sapiens ancestors sit together, as one of them paints on the wall, perhaps telling a story about the animals or spirits that govern the hunt. Outside, the wind howls on a cold steppe night. But here by the fire there is warmth and the presence of community. The flicker of flames brings the painted beasts to a semblance of life. A child, half asleep in a mother's lap, watches wide-eyed as her father or mother inscribes meaning onto the rock. In this moment is the root of what will become art, religion, science, all attempts to connect the inner world of thought with the outer world of reality. The physical evolution of humans was only the beginning. With the cognitive revolution, cultural evolution took over, far outpacing any biological change. After the Ice Age peaked around 20,000 years ago, and the glaciers began to retreat, climates changed, and some human bands started experimenting with cultivating wild plants and managing animals. The stage was set for the Neolithic Revolution, the advent of agriculture, roughly 12,000 to 10,000 years ago. In the fertile crescent of the Middle East, people domesticated wheat, barley, peas, goats, sheep. In China, rice and millet. In the Americas, maize, beans, squash, llamas. Agriculture was a double-edged sword. It allowed much larger populations and the rise of villages and cities, but also brought harder work, new diseases, from close contact with domesticated animals and dense communities, and social hierarchies. Yet, it enabled the accumulation of surplus food, which in turn freed some people to specialize in tasks other than food production. Potters, weavers, priests, chiefs. Civilization dawned, with writing, with recorded history, with complex political organizations. As humans built cities and monuments, they never ceased pondering the heavens that had always been their canopy. The same stars that guided nomads now became points of reference for farmers, scheduling plantings, and for sailors navigating seas. We begin to see astronomy rise alongside agriculture. Ancient Sumerians, Egyptians, Chinese, and Maya all tracked celestial motions and integrated them into their worldviews. Ancient myths about creation persisted and evolved, now recorded in cuneiform or hieroglyph or oral epics, but increasingly, some curious mind sought natural explanations alongside supernatural ones. Take Mesopotamia. By 1800 BCE, Babylonian astronomers could predict eclipses and had identified the planets wandering against the starry firmament. They still honored Marduk and Ishtar, but they also laid groundwork for a scientific tradition. In Greece by the 6th century BCE, philosophers like Thales and Anaximander speculated that the world might be made of natural elements, and that the sky wasn't just the realm of gods but of material spheres. The idea that the cosmos is comprehensible through reason was a momentous shift, the seed of science. Of course, the geocentric model, Earth at the universe's center, prevailed in antiquity. It fit both intuition and church doctrine in later eras. It took the boldness of Nicolaus Copernicus in 1543 to formally propose a heliocentric system, with the sun at center. Then came Galileo Galilei, who in 1609 aimed his telescope at Jupiter and saw 4 moons orbiting it, not Earth. He saw the phases of Venus, proving it orbits the sun. These observations shattered the crystalline spheres of medieval cosmology. Galileo's insistence that nature's book is written in the language of mathematics put him at odds with authorities, but it also made him the father of observational astronomy. Imagine Galileo peering through his crude telescope on a clear night from his garden in Padua, recording meticulous notes by candlelight. In those secretive notes, a revolution was brewing. Humanity's conception of its place in the cosmos was upended. No longer the center, Earth became one planet among many. It was a humbling insight, and yet a thrilling one. The universe was so much larger and stranger than we had thought. Then Isaac Newton, in 1687, published his Principia, uniting heavens and earth under the same laws of motion and gravity. The moon's fall and an apple's fall were explained by one theoretical framework. It said that after reading the Principia, the poet Alexander Pope quipped, Nature's laws lay hid in night. God said, let Newton be, and all was light. Newton himself was deeply religious in his own way, seeing his laws as revealing God's harmonious design. Spinoza might have smiled at Newton's work. Here was understanding the world as it is, which for Spinoza was the highest form of love towards God-nature. Newton's gravity held sway until Einstein's deeper insight that gravity is the bending of space-time. But that's jumping ahead. Parallel to cosmological understanding, humans sought to understand life itself. Charles Darwin, inspired by the diversity of creatures in the Galapagos and beyond, unveiled in 1859 the theory of evolution by natural selection. This was another paradigm shift. Life was not static or fixed since creation. It was fluid, branching, adapting, with all species, including humans, connected in one great tree of kinship. We were no longer separate from animals by divine fiat. We were animals, evolved from common ancestors. Though disconcerting to some, this idea also filled many with wonder. How astonishing that simple beginnings could lead, step by step, to the rich tapestry of life we see, and that tape continues to run. We humans were products of the same forces shaping the lowly beetle and the majestic oak. As Darwin wrote in the final lines of The Origin of Species, there is grandeur in this view of life, that whilst this planet has gone cycling on according to the fixed law of gravity, from so simple a beginning endless forms most beautiful and most wonderful have been, and earned our being, evolved. He captured that blend of the mechanical, fixed laws, and the magical, endless forms wonderful, that characterizes our scientific understanding of life. Following Darwin, the quest turned inward to the fundamentals of biology, eventually to the discovery of DNA structure in 1953 and the genetic code. With that, we learned a language in which life's information is written. A four-letter code, elegant yet robust, that has been passed down and modified for billions of years. And what of the stars? We left Galileo with his telescope and Newton with his calculus. Over the 18th and 19th centuries, astronomy advanced. Stars were found to be suns, incredibly distant. We discovered our galaxy's structure, and then in the 1920s, Edwin Hubble shattered the notion that the Milky Way was the whole universe. He proved that the spiral nebulae were entire galaxies outside our own, and moreover that the universe is expanding. This lined up with Einstein's general relativity, which had predicted either expansion or contraction. Einstein initially fudged it with a cosmological constant, but later called that his greatest blunder. The concept of an expanding universe implied a beginning in time, a big bang. That idea was contentious until the cosmic microwave background radiation was accidentally discovered in 1965, giving concrete evidence of a hot primordial universe. In the 20th century, humanity truly stepped into the cosmos, intellectually by understanding it, and physically by venturing off Earth. Sputnik in 1957, Yuri Gagarin's orbit in 1961, Apollo 11 landing humans on the moon in 1969. These were watershed moments. When Neil Armstrong took that first step on lunar soil, he remarked it was one small step for a man, one giant leap for mankind. In that grainy black and white footage, humans saw themselves for the first time on another world. We carried our dreams, our conflicts, our unity and division into space. But seeing Earth from the moon, a delicate blue marble against the void, many felt a profound shift. Mortality and unity of our species became clearer. The absurdity of our divisions, perhaps, more evident against the cosmic backdrop. Marcus Aurelius, meditating by his tent at night on campaign, would often remind himself of the impermanence of all things and the smallness of human life in the big picture. And indeed, the universe is transformation, he wrote. Life is opinion. To him, the churn of the cosmos dwarfed the concerns of one emperor or one war. Standing on the moon, astronaut Edgar Mitchell later said, "You develop an instant global consciousness, an intense dissatisfaction with the state of the world, and a compulsion to do something about it. The cosmos can be our balm and our mirror. It shows us how transient our quarrels are, and yet how precious our moments. In recent decades, our cosmic quest has only accelerated. The Hubble Space Telescope in the 1990s showed us galaxies billions of light years away, deep fields of countless universes within a patch of sky, no bigger than a grain of sand held at arm's length. And now the James Webb Space Telescope, launched in 2021, has opened the infrared eyes on the early universe, discovering galaxies from only 300 million years after the Big Bang. In cosmic terms, the universe's toddler years. Webb's images of the cosmic dome reveal surprisingly large and bright infant galaxies, suggesting the first stars and galaxies formed quickly, and perhaps in ways we didn't anticipate. We are peering back in time, seeing the faint light of the first stars, literally 13 billion years old, reaching us now. These modern achievements stand on the shoulders of all the seekers of knowledge before, from the nameless early human who first noticed patterns in star motions, to the mathematicians and inventors, to the scientists of every nation collaborate. Throughout human history, the night sky has been a source of inspiration, myth, and eventually, scientific inquiry. Early civilizations built megaliths and monuments aligned to solstices and equinoxes. Stonehenge in England, marking summer sunrise. The pyramids at Giza, aligning to cardinal directions. The Mayan city of Chichén Itzá, with its pyramid casting a serpent-shaped shadow on the equinox. These show an advanced awareness of celestial cycles woven into culture and religion. The ancient Sumerians tracked planetary movements and recorded eclipses. They associated planets with gods. Ishtar was Venus, Nergal was Mars, blending astronomy with astrology. The Greeks gave us the first model of the cosmos with mathematical underpinning. Ptolemy's geocentric spheres, which, though wrong, were a rigorous attempt to fit data to theory. It took nearly 1,500 years until Copernicus, and then Kepler, who discovered planets move in ellipses, and Galileo to dismantle the geocentric model. Galileo's trial by the Inquisition in 1633 is often cited as emblematic of the clash between dogma and free inquiry. Forced to recant heliocentrism publicly, he allegedly muttered, "Eper si move, and yet it moves," about Earth, whether apocryphal or not. That phrase rings true. Reality is what it is. Regardless of our beliefs, the quest for understanding often bumps against established authority, but truth has a way of leaking out. Just as the Grand Inquisitor in Dostoevsky's parable accuses Christ of burdening humans with too much freedom, saying, "Man is weak and cowardly, preferring security over truth," institutions have sometimes thought people not ready for unsettling truths. But intrepid explorers of knowledge, from Bruno to Galileo to Darwin, have bravely lit lamps in the darkness, trusting that illumination is better for humanity than comfortable delusion. Dostoevsky himself, through his novel characters, wrestled with human fragility and the longing for meaning. He swears to you that man is weaker and lower than you have ever imagined him to be. Man is weak and cowardly, he wrote in the voice of the Grand Inquisitor, and indeed, we humans are fragile, physically, morally, yet we are also capable of greatness, of wisdom, and sacrifice. The Cosmos story brings that duality into focus. We are insignificant and singularly significant. For after all, as far as we know, we are the only part of the universe that can reflect upon itself. The stars burn unthinkingly. The galaxies collide without witness. But here on Earth, a conscious mind can contemplate the age of starlight, the birth of time, and feel something: awe, joy, curiosity, perhaps spiritual reverence. The philosopher Sartre might remind us of our radical freedom in this regard. Man is condemned to be free, because once thrown into the world, he is responsible for everything he does. It is up to you to give life a meaning, in a universe that science reveals to be governed by impersonal laws. There is no intrinsic meaning handed down. We, the self-aware products of this universe, must infuse our lives with meaning through our choices, through love, through our creations. Sartre's existentialism can be sobering. No one to tell us why we're here, but also empowering. We decide why. We decide through the projects we undertake, through the values we uphold. Our growing understanding of the cosmos has not diminished the human spirit. If anything, it has given us more canvas on which to paint meaning. Where once our ancestors might have seen the stars as campfires of the gods set in a solid firmament, we now know them to be distant suns, many with their own planets. This knowledge has sparked one of the most profound questions of all. Are we alone? In recent years, thousands of exoplanets have been discovered. Some orbit in the habitable zones of their stars, where liquid water could exist. The possibility of life elsewhere is no longer idle speculation, but a target of empirical research. The James Webb Telescope is even studying exoplanet atmospheres for potential biosignatures. How poetic that we, made of stardust, arisen on this pale blue dot, now search the skies for siblings, for other eyes turned back at us in the cosmic night. Rumi, with characteristically mystical insight, wrote, "Stop acting so small. You are the universe in ecstatic motion." It's a reminder that our consciousness is not trivial. It is as grand in its way as the whirl of galaxies. When we think and love and create art, the universe itself is doing those things through us. If a star could sing, if a galaxy could dream, perhaps those would be akin to what human beings do. In the words of philosopher Alan Watts, through our eyes, the universe is perceiving itself. Through our ears, the universe is listening to its harmonies. We are the witnesses through which the universe becomes conscious of its glory, of its magnificence. This perspective bridges nicely to Spinoza's view of nature and God. Spinoza saw everything as one substance. We, and the stars and the amoebas, are just modes of it. Thus, to love God, for Spinoza, was to love the universe, to rejoice in its lawful order and its existence. God is the indwelling and not the transient cause of all things, he said. There's a deep comfort in that pantheistic view. We are within the divine, always. We do not need to seek God beyond the stars. God, or at least the sacred, is right here in the soil, in the sunlight, in each other, under a clear night sprinkled with stars. A Spinozist might feel an overwhelming sense of unity, whispering, "This is God nature, and I am part of it." The journey of civilization's cosmology went from mythos to logos, from mythic explanations to scientific ones. But the myths were never truly left behind. They persist in new forms. The Big Bang can be seen as a new creation myth. From a singular origin, the entire cosmos unfolds. The details differ, but the narrative arc, a beginning, a development, perhaps an end, resonates with the old stories. The difference is our modern story is backed by mathematical equations and observation, yet it too requires a kind of faith. Faith in reason, in empirical method, in the consistency of natural laws. We also still contend with how to fold human values into a vast, value-neutral cosmos. Here, literature and philosophy continue the conversation that science opens. Writers like Dostoevsky probed the human psyche confronted with freedom and despair. Fyodor Dostoevsky wrote much on human fragility and moral freedom. In The Brothers Karamazov, Ivan wrestles with the suffering in the world and the existence, or non-existence, of God to justify it. Nietzsche, witnessing the death of God in modernity, challenged humanity to create its own meaning and morality in the face of an indifferent universe. Jean-Paul Sartre took that further, as we saw, declaring man condemned to be free, having to choose meaning in a meaningless universe. Simone de Beauvoir and Hannah Arendt considered what freedom means in the context of society and politics. Arendt in particular noting that true freedom is action, in concert, beginning new things together. Arendt also feared how fragile our constructed world is, how easily freedom can be surrendered to authoritarianism out of fear. She warned that if we shy from the burden of freedom, we risk tumbling into darkness. Yet, when gazing at the stars, one might also feel what Immanuel Kant expressed. Two things fill the mind with ever new and increasing admiration and awe: the starry heavens above me and the moral law within me. Despite all our knowledge, the night sky's beauty and vastness continue to move us deeply, and our own capacity for moral judgment and goodness stands as a sort of miracle in itself. In the final reckoning, as our narrative comes to the present day, we find ourselves lying under a sky, perhaps not very different from that which our Paleolithic ancestors saw, except that we have greatly dimmed it with city lights. Still, find a dark pocket, and the Milky Way reveals itself as in olden times. In such moments, profound questions often arise spontaneously. What is time? What am I in this grand scheme? Why is there something rather than nothing? Oh, these are ancient questions, refreshed anew by each generation. Time, what an enigmatic thing. Einstein taught us that time is relative, bound up with space into space-time, warped by gravity, relative to observers. And quantum mechanics suggests time might not be fundamental at the deepest level, or at least that our intuitive flow of time doesn't apply in the same way. Philosophically, we wonder, is time an illusion? Einstein's letter to Besso's family, after the death of his friend, Michel Besso, included the consoling line that for those of us who understand physics, the distinction between past, present, and future is only a stubbornly persistent illusion. He meant that in relativity, all times exist in a four-dimensional block universe sense. Time is like another dimension of space. This can be comforting. In some sense, Our lost loved ones are not lost. Their worldlings exist eternally in space-time. But experientially, we feel the flow, we suffer irreversibility. St. Augustine, in his Confessions, famously grappled with time. The past is no more, the future is not yet, only the present is. And even the present is fleeting. So, what is time? Our best physics says time began with the Big Bang, at least time as we know it. There may be something beyond, but we have no evidence, and time may stretch indefinitely into the future if dark energy drives eternal expansion. But an eternal, expanding universe still has a thermodynamic story. Stars will burn out, matter may decay, and the cosmos could approach a heat death. Maximum entropy, no free energy to do anything. That paints a rather desolate picture of the far, far future. It's a vision of temporal mortality on the cosmic scale. Not only do we individuals die, but perhaps all structured activity in the universe eventually dies out. This raises the existential question: if the universe itself will end, either in heat death, or a big rip or collapse, or some quantum tunneling catastrophe, does that render everything meaningless? Some might say yes. Why strive, if all is doomed to vanish without trace? But consider, the meaning of a beautiful piece of music isn't in its final note. It's in the rich experience throughout. The journey can have value, even if it doesn't last forever. As Marcus Aurelius put it, that which is ephemeral, yet can be noble. Impermanence does not negate meaning. It shapes it. We cherish things more when we know they won't last. The Japanese concept of mono no aware, the gentle sadness of things, an awareness of impermanence that heightens appreciation, captures this well. Cherry blossoms are lovely because they bloom briefly. For mortals, the easy life of the gods would be a lifeless life, Arendt reminded us. It is precisely our mortality that galvanizes us to love deeply, to create fervently, to seek purpose. Nietzsche's idea of eternal recurrence was a thought experiment. Imagine if you had to live this same life over and over, infinitely. Would you despair, or would you embrace it? He wanted us to live in such a way that we could joyfully say yes to the prospect of reliving our lives eternally. He knew nothing about modern cosmology. Of course, it was an ethical rather than physical point. But interestingly, some cosmological models, like certain cyclic universe models, do evoke an eternal return of sorts. Regardless, as a metaphor, it's powerful. Live so fully and so honestly that you would gladly repeat your life. If one achieves that attitude, moment to moment, one has achieved what Nietzsche called amor fati, love of one's fate, love of the necessity of things. In a universe indifferent to us, we can choose to affirm it and our place in it. Rumi, ever the romantic mystic, would speak of love as the binding and redeeming force. The atoms within us are held together by forces, but perhaps the emotional force that holds communities and families together is love. An emergent cosmic force as real as gravity in its effects on our lives. Love is the bridge between you and everything, Rumi said. When we love, be it a person, a pet, a place, or the cosmos itself, we connect a tiny finite self to something greater. We transcend some of our isolation. In a cosmic perspective, one might feel lonely, a single consciousness amid billions of light years of mostly emptiness. But as Rumi so beautifully said, do not feel lonely. The entire universe is inside you. We are never truly alone, because we contain multitudes. Literally, we have atoms from distant stars. Metaphorically, We carry the stories and names of millennia within our minds, and spiritually, one could say we are connected to the source of being. When we think of the future of the universe, we should also consider the future of our universe, the Earth and humankind. We live in a precarious time where our technological might has outstripped our wisdom in some respect. We face threats of climate change, ecological collapse, nuclear weapons, problems that require global cooperation and foresight. From space, national borders are invisible. The Earth is one system. Will we mature to see ourselves as a single human family with a common destiny? Or will we be like squabbling clans oblivious to the greater risk? The cosmos will continue with or without us, but what a shame if without, for we are a part of the cosmos. Carl Sagan said on viewing the pale blue dot photo of Earth. That's here. That's us. A mote of dust suspended in a sunbeam. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. Yet he also urged, for the moment, the Earth is where we make our stand. Thus, gazing forward, perhaps our cosmic story's next chapters will involve humanity spreading beyond Earth, safeguarding life's continuity. Or perhaps AI, our silicon descendants, will carry the torch of consciousness further. Or perhaps we'll join some galactic community if life is common. Thus far, it seems lonely. The Fermi paradox. Where is everyone? The unknown beckons us, as it always has. As we drift toward the conclusion of this long narrative, equal parts fairy tale, science, history, and philosophy, let's return to the personal scale, to the present moment, which is all any of us ever truly has. You, dear reader, or listener, lie perhaps under a blanket of stars, or snug in bed with the lamp glowing softly. The day's worries are settling. Let the enormity of time and space not frighten you, but soothe you as a lullaby of perspective. Feel the peace of surrendering your small self to the great flow of being. Like a single note in a cosmic symphony, you belong and are needed to complete the music. Recall the everyday images woven through our tale. A child stares at the stars, eyes full of wonder. That curiosity is the seed of all science and myth. The quiet hum of a train at night, time's relentless movement, carrying us all, yet with a comforting regularity. The smell of soil after rain, life renewing. The earth nourishing her children. A candlelit room where someone studies an old astronomy book. The warm light of knowledge pushing back the surrounding dark. Morning coffee while sunlight filters through a window. The simple joy of existence, here and now. Brought to you by photons that traveled 150 million kilometers from the sun, which itself condenses 5 billion years of cosmic history. These little moments are not separate from the grand story. They are the story. At the human scale, where experience resides, our narrative thus far has spanned from the Big Bang to the present day. In doing so, we've seen that science and philosophy and art are all part of one continuum of human attempts to understand and to feel at home in the universe. We started with Humankind, how the world was formed, and ended with, what do we make of it? The world formed without us, but its story continues through us. Before we close, let's allow a few more voices from history to murmur their wisdom in our ear. Marcus Aurelius reminds, accept whatever comes to you woven in the pattern of your destiny, for what could more aptly fit your needs? He invites us to trust the larger process, which in cosmic terms is the unfolding of nature. Albert Einstein, filled with a childlike awe, said, the most beautiful thing we can experience is the mysterious. It is the source of all true art and science. He saw mystery not as something to fear, but as a fountain of wonder, that drives us to discover. And indeed, each answer we find begates new questions, an endless unfolding mystery. Rabindranath Tagore, the Bengali poet, wrote, "The same stream of life that runs through my veins, night and day, runs through the world and dances in rhythmic measures. That stream of life is an emergent thread in the cosmic tapestry, and we get to join the dance for a short while. In wrapping up, we might wonder, like a refrain, are we the cosmos becoming aware of itself? All evidence suggests yes. We are made of the cosmos, and we see no sign of other cosmic self-awareness yet. So, in a profound sense, we are the universe's consciousness. This could be seen as our significance, not the old hubris of being the center of creation, but the unique role of being a mind for the universe. If one adopts this perspective, then nurturing and expanding consciousness, ours, we become the eyes, ears, and heart of the cosmos. What a destiny, and what a responsibility. It makes petty cruelties and selfishness appear not just immoral, but cosmically tragic. A failure to live up to the universe's hopes embedded in us. Conversely, every act of kindness, every truth uncovered, every beauty created, these become our offerings back to the cosmos that gave us birth. As the Quaker saying goes, let your life speak. Let it speak for the cosmos in gratitude and joy. We set out to tell how the world was formed, from the Big Bang to now. And so we did. But perhaps we also told how meaning was formed, bit by bit, from the fundamental forces and particles, to stars and planets, to microbes and mammals, to maths and equations, to reflections at midnight. This meaning is not external. It is woven by the interplay of what is with our own consciousness. In the end, maybe the Greek philosophers were right in a way. The universe is a cosmos, an ordered whole, not just in the physical sense, but in the sense that it includes us and our striving for order and understanding. In a gentle night breeze, one might almost hear a whisper among the swaying trees, as if the universe itself were telling its story through every rustle and chirp. It's a story with innumerable threads and no definitive end, but we find ourselves, miraculously, as characters in it, and also as its fortunate narrators. The final lesson of this deep journey may be simply this: wonder. To maintain a sense of wonder is to be continually receptive to the beauty and mystery around us. As we drift off to sleep, the universe's story doesn't stop. Our heartbeats and breath follow ancient rhythms. Our neurons play out electrical impulses set in motion by stimuli and thoughts that trace back to all we've experienced. In the morning, the sun, a middle-aged star, will rise for us again, as it has for over 4.5 billion years, shining on an earth teeming with life that emerged by the laws of nature, yet exceeds them in meaning. Let us close with a reflection from Sufi poet Rumi, who so beautifully merged love, nature, and the cosmos. The universe and the light of the stars come through me, he wrote, and shine like the whole universe is yours. May we shine with understanding and compassion. May we carry the universe within us gently, as a beloved story we are helping to tell. And when we finally fall asleep each night, may it be with a sense of peace, as if lying under the stars, feeling the slow turn of the earth, part of that ecstatic motion Rumi spoke of, connected to all that ever was and ever will be. In that peace, we recognize that our mortality is not a curse, but what gives our life a shape. As Marcus Aurelius observed, everything is only for a day, both that which remembers and that which is remembered. Yet he did not despair. He found in that truth a call to virtue and presence. We too can find meaning not in everlastingness, but in the quality of each day we live, each connection we make. Our story of how the world was formed thus ends where it began, in a sense of quiet awe at existence itself. The world formed and continues to form, and we, in telling its story, are also continuing the act of creation in a human way, forging narratives and understanding out of the raw material of reality. So, dear friend under the stars, sleep well. The universe will hum its ancient tune through the crickets and the distant galaxies as you dream. Perhaps you'll dream of flying among those galaxies, or walking in a primordial forest, or meeting sages of old. When you awaken, the world will still be turning, the sun awaiting you with its golden light, ready for you to live your part in this magnificent cosmic tale anew, eternal, yet ever new. This tale of the universe goes on, and we are each a precious word in its endless narrative.